So yeah, hi guys, welcome to our next session based on our chapter 7. Today we are going to begin with a very interesting chapter. This chapter is quite similar to the one that you had learnt in your class 9 also. I guess you had learned that in class 9 where you understood the concept of congruency, right? You guys remember that chapter and this chapter both are quite similar, but in this chapter you are going to be learning some new concepts along with some basic congruency criteria. There you had just learnt about the term congruency. Here you are going to make sure that the two figures are congruent. I will be explaining each and everything in detail, starting with the basic difference between congruency and similarity. This is the often mistaken concept that you or we as people consider congruent figures and similar figures to be the same thing. Actually, both of those figures are totally different. I will be explaining each and everything in the coming videos, in the coming portion of this video, and also the coming videos as well. We will be completing this chapter in around 4 or 5 settings, I guess, hopefully in 5 settings, but most probably in 4 also. So we are going to begin now. Remember, this entire chapter is purely based on your triangles. We are going to learn each and everything regarding a triangle. So everything that you have learned up till now with respect to your lines and angles, that will come handy because you will be combining 3 lines and 3 different distinct points which are non-collinear together. If you are joining them, you will be getting a figure which is a triangle, and we will be then following up with the properties related to it. So remember, you have to recall each and everything from your class, your chapter 6, then come to this video. Now let's start with the video and see what do we have now. So what is a triangle? It is very easy thing, you guys already remember. A closed figure formed by joining 3 non-collinear points on a plane is a triangle. In simple language, if you have 3 distinct points such that none of these 3 points are lying on the same line, that means these points are non-collinear. If you join all these 3 points, that means if you join these 3 points with 3 different lines, this figure right here, or you can say this figure right here, this will be what? This will be a triangle. Now triangles have what? Triangles have 3 vertices, A, B, C. Now the term vertex, what is a vertex? You guys know, a point from where 2 lines either emerge or they meet. Now you guys see, if I have 2 lines right here, I have a line segment BA and I have a line segment CA. Now you guys see, BA and CA are meeting at point A, so A is what? A is a vertex. Similarly, AB and CB both are meeting at B, so that will be B as a vertex, and then you have C as a vertex. And plural of vertex is what? It is vertices. So vertices are generally the points from where either the 2 lines emerge or they meet, and they have 3 distinct angles. Now this is quite simpler, you guys can already guess this one. Since we have 3 vertices, then the distance between 2 adjacent arms, that will be an angle. So in triangle you have 3 angles, and the name itself also states the same thing. Triangle. Tri means 3 angles. So a figure which has 3 angles and none of those 3 are on the straight line, they are not on a straight line, that figure will be a triangle. Or simply you can say 3 distinct points joined together will be forming a closed figure called your triangle. So let's move forward and see different types of triangles. Now you guys already know the types of triangles, that is a topic of our earlier classes. So first triangle type is your equilateral triangle. So equilateral triangle is what? It is that kind of triangle in which each of the side is of same dimension and each of the angle is of same degree. That means each angle is 60 degree. In equilateral triangle, angles are 60 degrees each, and each side is equal. AB is equal to BC is equal to A. So that is the main thing regarding equilateral triangle. Now you have isosceles triangle. Isosceles triangles are those triangles in which you have a pair of adjacent sides equal. That means if AB and AC are equal, then this kind of figure is what? It is a triangle which is an isosceles triangle. Keep in mind the spelling of isosceles is this one, isosceles, right? Then you have the case of scalene triangle, and with respect to the angles here, you will be understanding this portion later on. So in isosceles triangle, if the 2 sides are equal, that means if these 2 sides are equal, then base 2 angles will be equal. So in isosceles triangle, 2 sides are equal and pair of 2 opposite angles or the base angles opposite to the equal sides are also equal. That is a property of an isosceles triangle. We will be discussing this later on with this coming video or with this coming session. Now we have the next type of triangle, which is scalene triangle. Now what is a scalene triangle? This is quite simple. You guys already remember this one. Scalene triangle is that kind of triangle in which each side is of different dimension. You guys see a 4 cm, a 5 cm, sorry, an 8 cm or a 12 cm. All of these three sides are of different dimension, and each of its angles will be of different degrees as well. So in equilateral triangle, all angles are equal, all sides are equal. In isosceles triangle, a pair of adjacent sides are equal, and the angles opposite to those equal sides are also equal. And in scalene, none of the sides are equal and none of the angles are equal too. Then you have the concept of what? Then you have the concept of right angle triangle. So a triangle in which one of the angles is of 90 degrees, that will be a right angle triangle. And you have then acute angle triangle. Acute angle triangle is that kind of triangle in which each angle is less than 90 degrees. You guys remember what is an acute angle? Any angle x will be acute if it is less than 90 degrees. So in an acute angled triangle, each of the angle will be less than 90. You guys see a 70, a 50 and a 60, right? So these will be the cases. Now for the case of obtuse angle triangle, obtuse angle triangles are those triangles which have one of the angles which will be more than 90 but less than x will be an angle which will be more than 90 but less than 180. So in a triangle, if one of the angles is more than 90 but less than 180, that kind of figure will be an obtuse angle triangle. Remember, in acute angle, acute angle triangle, each and every angle can be less than 90, but for the case of obtuse, not more than one angle can be obtuse. See, the condition for a triangle is this, that sum of all angles, if I have a triangle, then sum of its all interior angles has to be 180. So if you have more than one angle which is more than 90 degrees but less than 180, let's say if this is 91 and let's say this is also 91, if that had been 91, then sum of these two angles would have been 182 degrees, which was not possible since for a triangle, the maximum sum of all three angles has to be 180, or you can say exactly 180. Not maximum, it should be exactly 180. If it is less than 180, then the figure cannot be a triangle. If it is more than 180, then again that figure cannot be a triangle. So this is a most important thing. Remember, if you're talking about triangles, then each of the angles inside the triangle, that means all three angles will amount to 180 degrees. That is the most important thing of this portion. Now let's move forward and see what do we have now. So idea of congruency. Before we get to the point, what is the meaning of congruence? Now for this, I'm going to do what? I'm going to take some examples and you guys will be understanding this. See, if I just give you an example, let's say you went to a shop, you went to a stationery shop, you asked the man there that give me a notebook. You did not specify which kind of notebook you want or which kind of brand do you want for that notebook. You just wanted a notebook. Remember, there is a difference between a notebook and a long notebook, right? Long notebook is generally the registers that you guys talk about. These are like that, right? Long notebooks are like this, and generally notebooks are like this. They are a kind of a square, or you can say, if you have purchased a notebook, let's say it was a square notebook, right? You have purchased this notebook, let's say it is rectangle, it cost you rupees 20. Okay, then you went to another shop, you bought the same notebook, or you can say the same type of notebook, it actually cost you rupees 22. Now guys, see, if you try to place them together, congruency states that two figures can be termed congruent if they exactly cover up the if you just place one figure on the another, that will exactly cover up the second figure. See what I am trying to tell you. If you just hold up your palms, see, if you have your palms with you, see, though both are palms right here, if you just place them together, see, if I just put it like this, you guys see, you can see only this palm, you cannot see the hand which is behind my hand which is in front of you. So guys, see, both of these hands are actually congruent to one another. They are exactly covering up one another such that if you look at the top view or the bottom view, you can only see just one type of figure. You cannot see the other one. Now in this case, you guys can see here, I have these two figures right here. See, I have triangle ABC, I have triangle EDF. Now guys, see, if I just generally replace this one and write it like this, if I just draw it like this, now guys, see this figure BAC, that will most probably be covering this one up. See, it seems like they are of equal dimensions. So two figures with exactly same size and same shape, those figure will be a congruent figures. But for the case of your similar figures, what is the difference between a similar figure? See, the common difference is this one. Let us assume a rough, you can say a long notebook and generally a notebook. Okay, you guys see both of the notebooks can be rectangle, right? Their shapes can be rectangle. Long notebook exactly will be a rectangle, and a normal notebook can be a rectangle. Now you guys see both of them are resembling the same shape, but their sizes can be different. Their actually the main thing is that sizes can be different. The shapes can be same, they can be rectangle, they can be square, but there's difference, there is a difference between their sizes. So such kind of figures are your similar figures, not your congruent figures. Now for this case, if you consider hands, let's just take this example. Some people have smaller hands, some people have bigger hands, or you can say larger hands, but hands are same, right? They are for the same purpose. So hands are technically similar. They will be having, mostly they will be having 5 fingers, or you can say 4 fingers and 1 thumb, right? So each of these things is similar to everyone. They are sharing the same kind of orientation in their hands. So those figures are what? Those hands are similar. They are not congruent. But if you're talking about both of your hands, if you just join them together, if you bow your hands, you will be having what? Your both hands will be covering each one, everyone, each of the other completely, and that kind of figure will be the congruent figure. So in this case, you guys see I have 2 squares with me. If I place them together, they seem like they have the same dimensions and they can easily cover up one another. So that will be the case of congruent figure. Similarly, these 2 circles right here. So congruent figures are those figures or 2 objects, they will be termed as congruent if they exactly cover one another. They have the same shape and same size. But if in this case, if I had this triangle and if I had this triangle, you guys see if I had a triangle like this, ABC, now these 2 triangles cannot cover one another, so they will not be congruent. So in this case, they need to have the same shape and they need to have the same size. Their angles can or cannot be same. Actually, the thing is, I will be explaining it later on. So congruent figures, you have some congruent examples right here. See congruent figures, same shape, same size. Not congruent figure, different shapes. You guys see one is right angle and another is somewhat in a isosceles, or you can say a scalene. Not congruent, different sizes, because triangles are of same size but same shape, but their sizes are different. See, this figure is bigger and that one is smaller. If you try to place this one on that one, this will be covering up just this much area and you can see the bottom figure. But according to congruency, you cannot see either of the figures if you're looking from top or bottom. So you can only see one figure at a given time. But if you look at this one, you will be seeing the bottom one as well and the top one as well. See, these 2 figures are congruent. This one is horizontally, it is lying horizontally, and this is lying vertically, but they are congruent because they are sharing the same shape and same size. But in this case, you guys see, this is a trapezium, this is a rectangle, different shapes. This both of these are rectangles, but their sizes are different. They can be similar, but they will not be congruent. So that is the thing that I was telling you. So let's move forward and see. So congruency of triangles. Now we are going to talk about congruency of triangles, specifically triangles. So congruency states that 2 figures will be congruent if all 6 pairs of the corresponding parts are congruent. Remember this, all 6 pairs of the corresponding parts. That means these 2 triangles will be termed congruent if AB, side AB is same as ED, or you can say DE, BC is same as EF, and AC is same as DF. If all these 3 sides are same, or you can say congruent, then both of the triangles will be congruent. And there can be this also, their angles have to be same too. Angle A should be same as angle D, angle B should be same as angle E, and angle C should be same as angle F. Now remember this, in order to prove 2 figures congruent, you need to have at least one side congruent. In order to prove 2 figures congruent, you need to have one side congruent, or you can say one side equal. The reason being this, I will be explaining this one. Why, if we have 3 angles, just 3 angles equal, the figure is not a congruent figure. I will be explaining this later on while we study the concept of or the criteria of congruency. But for now, remember this, if in a pair of triangles, the corresponding parts of one triangle is same as the corresponding parts of the another one, so that will be the case, those figures will be congruent. So if AB is equal, or you can say AB is congruent to DE, BC is congruent to EF, AC is congruent to DF, thus these 3, you can use side criteria and you can say triangles are congruent. Or if you have these 3 angles, then you cannot say just on the basis of angles that the triangles will be congruent. I will be explaining this later on. For congruency, you need to have at least one side congruent. Remember, at least one side has to be congruent if you are making sure that the pair of triangles are congruent to one another. That is the necessary thing. I will be explaining this in a bit. Let's start with this one. So we have some common criterions for for congruency. First one is side criteria. Second one is side criteria. Third is angle side angle, and fourth is angle side. This is the proof of this angle side angle criteria. This can happen, but remember there is no such criteria which is side side angle. There is no criteria like this, and there is no even criteria like this, angle angle angle. These two kind of criteria are not there. We have these four criteria along with one more criteria which is right angle hypotenuse side. This is another criteria that we will be discussing with the coming videos. This is a very important criteria if we are talking about right angled triangles, but generally we will be using these four criteria to prove our congruencies of two pairs of triangles. Now let's see the first one, the side 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 criteria. This criteria states that in a pair of triangles, if three pairs of corresponding sides are congruent with one another, that means if a line segment AB is congruent to DE, if line segment BC is congruent to EF, and if line segment AC is congruent to DF, then you can say the both of the triangles are congruent using which criteria? Side 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 criteria. Now for this I want to tell you one more thing. In congruency you have to make sure that your names are accurate. Your names must be accurate. See, the thing is, the reason being this, if I just go back to the video, let's just go back to the slides and observe these 2 points. Now I had these two triangles with me, right? BAC and EDF. Now guys, see, it was clear that angle A and angle D both were sharing a right angle, and this B has to be lying on this E, A has to lie on D, and C has to lie on F. If that is the organization, if I somehow place like this, if I place my triangle over that, that means in order to successfully place triangle BAC on EDF, I need to have the proper vertices lying on the proper vertices. So that means in this case, we have to have this vertex C should be lying on F. So vertex C should be congruent to F. Sorry, so this will be C. Similarly, vertex A should be congruent to D. So A should be lying here, and vertex B should be congruent to E. B should be lying here. So this is the correct naming. You cannot alter the namings, because if you had taken the other name, let's say you somehow had placed it like this, for on the vertex D you had put B. Now guys, see, this B was not 90, this D was 90. So if you had successfully placed that one, your figure should be looking like this, right? Where this will be A, this will be B, and that point will be C. Now guys, see, none of the two figures are completely covering one another, so these two figures will not be congruent. So remember, naming is an important thing. You cannot ignore the naming of congruent figures. So you have to name them absolutely as the way they are. So that is the main important thing that you should understand. So in order to successfully place them, call them congruent, I need to have something like this. This BA can be congruent to this ED, considering B is on the outside, E is on the outside. So B should be opposite to E, A should be opposite to D. Then AC will be same as DF, right? See, A is lying on A is lying on D, so it has to be like this. A should be opposite to D, C should be opposite to F, and ultimately BC will be same as EF, considering B is opposite to E and C is opposite to F. Then you can say triangle BAC is congruent to triangle EDF, considering B is opposite to E, A is opposite to D, and C is opposite to F. Using which criteria? We have only used sides, so this will be the side 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 criteria. So remember, naming is important. That's why I have taken this example. Now let's come back to the congruency portion. So that was the case. Now in this case, you guys see AB is same as DE. So in this case, you guys see A should be opposite to D, B should be opposite to E, and C should be opposite to F. So if you name the congruent triangles, they will be like this. If you have named them ABC, then in place of A, you will be having its opposite vertex, which will be D. In place of B, you will be having E. In place of C, you will be having F. So this will be an important thing. Remember, side 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 criteria deals with only sides, and you have to name the sides properly and name the triangles properly too. That will be the main thing. Now let's move forward and see what do we have now. So side angle side criteria. Now in this case, the thing is two sides and the angle between those two sides, they will be congruent. Now the name itself states that you will be given a side and another side and the angle between those two sides. If those all 3 points are congruent to the other one, then you can say you have used the side angle side criteria. Remember, there is no such thing as side side angle criteria. I will be explaining it later on. But for now, remember this: if you want to use an angle in two sides, then you need to have something like this. That angle should be the common angle to both of the arms. That means that angle will be forming at the common vertex, which is sharing the both arms. So you guys see in this case, AB is equal to DE, AC is equal to DF, and angle A is equal to angle D. Now you can write them accordingly. You can write them like this also. AB is equal to DE. You can write this like this also. AC is equal to DF, and angle A is equal to angle D. That does not matter as long as you guys see angle A is lying between these two and angle D is lying between these two. So this will be side angle side criteria. Remember, this is not side angle criteria because there is no such thing as side angle. I will be explaining this, but it would be healthy, if it would be better if you are placing the common angle, or you can say the angle between the equal sides in between their proofs. So if you are writing them like this in this order, that will be healthy, that will be better, but you can write them any other way, but you just have to make sure that the congruency should be side angle side. It cannot be side angle congruency because there is no such thing as side angle. I will be explaining it now. So before we get to the point, we have angle side angle criteria. This states that, like the name itself states, there will be two angles which will be congruent to the other two of the triangle, and the common side will be congruent to the common side. That means if you observe this A, B and these two angles, similarly if you observe DE and these two angles, you have angle A same as angle D, AB same as DE, and B angle will be same as E. So you guys see, if something is like this, if angle side angle is there, then the side has to be in the middle. That means the common side. Its either angles are equal to the either angles of the opposite triangle or the second one. Then you can say you have used the congruency criteria, which is angle side angle criteria, which is totally acceptable. You can have this one also, angle side criteria. That is totally acceptable too. But remember this is angle side angle. Now let's move forward and see angle side. In this case, you have two indefinite angles. See, these are the two angles which are equal, and a third side is equal to the third one. See, the common side is not equal, any other side is equal. Now this can totally be acceptable. See, if I have an angle, let's say I have a line segment, we can easily create this one. Let's say this is 5 centimeter and this is 5 centimeter, such that I have been given this angle. Let's say this is 40 degrees, this is 50 degrees, this is 40 and that is 50. Okay, I'm going to prove this one why such angle side exists. You guys see 40, 50, this is 90. So this angle C will be 90 as well. And this angle F, this will be 90 as well. Now you guys see, you have a base which is 5 centimeter. And if you just plot them like this, let's say this is BC and let's say this is EF. So at C you have an angle of 90 degree. You can easily construct that angle, right? Let's say this is a 90 degree angle. You don't know the dimensions. You just drew a longer side, right? Similarly on F, at F you did what? You created an angle of 90 degree, right? So this is another angle which is 90. Now you guys know angle B is of 40 degrees. Now when you construct an angle of 40 degrees, it will be cutting your this side, this 90 degree angle at some point. This point will be A. Now you have easily constructed angle triangle ABC. Similarly, you guys know E is what? E is 40 degrees as well. So this will be 40. If I construct an angle of 40 degrees, this will be intersecting this 90 degree angle at this point. This will be point D, and you guys see both of these two angles, they automatically will be of 50 degrees. Now you can easily prove this one. You can just take the help of your compasses. You just do what? Take these two triangles. Let's say this is 5 centimeter and let's say this angle is easy 60 degrees. This angle is, let's say, 30 degrees. Then you can already construct this one. Similarly, construct another one in which this is 5 centimeter. This angle right here, that is let's say this is 60 degrees and this angle right here is 30 degrees. Then you have to construct this angle. Now this is quite easy. You can easily solve this one. You can prove them that it is easier to construct a triangle when two angles and a third side is given, but it is not easy to construct when two sides are given and a third angle is given. Now for this case, what we can do in this, let's see. Now I'm going to explain why there is no such thing as side angle criteria. Now bear with me, this is an important thing. You should be understanding this in deep. So according to this, we need to have a side and an angle. For this, I'm going to do what? I'm going to assume a triangle. Let's say this is a triangle A, B, C. such that AB is 5 centimeter and BC is, let's say, 10 centimeter, and this angle right here, it is 40 degrees. Right? Now guys, see, if I just have another triangle. Now in this case, see here, this is DEF. Let's say this is 5 centimeter, this is 10 centimeter, and this is 40 centimeter as well. But the thing here arises that we don't know this dimension. I can just move forward and construct 40-degree angle like that also, right? It can happen. We can do what? We can just take this side. See, if I just do what? If I just change this one, if I just have this also, if I consider this, let's say this is DEF. In this case, I know this is 5 centimeter, this is 40 degrees, but we are not sure whether this is 10 centimeter or that is 10 centimeter. Now what can happen is we can alter the dimension also. This can be falling here. Now you guys see, we can construct 40-degree angle anywhere, but the dimensions will be different, or that's why we can say it is impossible to construct a triangle with an unknown side. Two of the sides are equal and another angle is equal, because 40-degree angle can be made here also. That can happen too. See, we have two sides and one angle. It can happen here also. We can construct it here also. The dimension is not same. It will not be fixed, and we cannot assume that it will be actually falling here or it can fall here like this. Right? We can construct any angle. See, if I just draw it normally, see, let's say this is the case. ABC is a triangle. This was 5, this was 10, and that was 40. We can do what? We can just easily construct a triangle in which we can do what? We can just pick this one side and we can just put it here. Now you guys see, this will be 5 centimeter, but this will not be 10, right? Angle is 40 indeed, this is 5, but this will be on the outside, and there will not be any such thing which should be called your side angle. Or quite easy, you can do this also. There are various ways to explain this one. See, I had this example, right? ABC. This was 5, this was 10, this was 40. That could have been this also. This 10 would have been this one, this 5 would have been here. Then you guys see, if I had another triangle in which we had this dimension. Now you guys see, this was DEF, in which this was indeed 40, this was 10, but this was 5. Now you guys see, this figure, if I place it here, that will not be the same case, because this side is not similar to that one. So that cannot happen. There is no such thing as side, and that is the proof. If I just erase this, if you just compare both of the sides, you guys do have a 5 centimeter side, a 10 centimeter side, and a 40 degrees angle, but this side is unknown. Similarly, you have a 40-degree angle, you have a 10 centimeter side, you have a 5 centimeter side, but this side seems smaller than AC. So if you place this triangle right here, it will not be covering it up exactly. So henceforth, there is no such thing as side angle. Now let's move forward and see why there is no angle side thing. Now for this, I'm going to assume two equilateral triangles. This is quite simpler to prove. Let's say I have two equilateral triangles. I know in let's say DEF and ABC are two triangles such that they are equilateral. All of these sides are equal. This angle is 60, that angle is 60, that angle is 60. This angle is 62, that angle is 62, that angle is 60. But in this case, I have a side which is 5 centimeter, I have a side which is 7 centimeter. Now you guys see, angles are same, but the dimensions are different. This figure will be quite larger. It will be like this. And if you place this one, it will be falling in like this. So you guys see, if you place DEF on ABC, you guys will be having a portion which will be left like this, and this will be not. This will be the proof that why there is no such thing as angle side, because angle, because angles, there is a similarity criteria, which is angle similarity criteria. Two equilateral triangles are similar, but their sides have to be equal to in order to make them congruent. So if you have been given two equilateral triangles and their sides are equal, then you can say they are congruent. But if you are just only given that there are two equilateral triangles but their sides are different, then you can say they are similar but they are not congruent, because sides will be different and it will not be having the same size. Size will be different, obviously. So let's move forward and see what do we have. So we have the congruency criteria with us. Let's just wrap them up. I will be explaining, Sorry, I am having a bad throat. So if I just focus on this, I will be discussing this congruency criteria later on. But for now, assume these four. So we have this side angle side, two sides and angle in between those two sides. If that is the thing, we will be using side angle side criteria, angle side angle, two angles and the side sharing both angles. If that is the thing which have been given on both of the triangles, then we will be using angle side angle criteria. Then angle side, if we have two angles and a third side equal, we can easily construct the triangle and henceforth we can use the congruency. And lastly, we have side criteria, in which all of the sides will be equal and we can easily calculate, or we can easily prove that the given figures are congruent. Now let's move forward and see what do we have. So now we are going to start with our exercise 7.1. This is quite easy. We have what? In quadrilateral ABCD, AC is equal to AD. AC is equal to AD. AB bisects angle A. AB bisects angle A. That means this portion right here will be same as that one. That means angle CAB will be same as DAB, because it is bisecting angle A. I have to show that triangle ABC and ABD both are congruent. That means these two triangles have to be congruent. So this is quite easy. For such proofs, you have to do what? You have to follow these steps. Firstly, you have to write given. For this, you are going to do what? Write given each and everything. I know AC is equal to AD and AB bisects angle A. So that means angle CAB, remember CA should be opposite to D. If I just fold this figure from the middle, C will be falling on D, A and B will be a straight line. So remember, C will be opposite to D. So angle CAB will be equal to angle DAB, right? D and C are opposite and A and B are same. So this will be the main thing. Required to prove is what? Required to prove is triangle ACB congruent to triangle ADC. Or you can say ABC and ABD. Choice is yours. You can name accordingly. But I do know C is opposite to D. So ACB and ADC. So for proof, we are going to do what? Let's start with the proof now. In triangles ACB and triangle ADB, I can see AC is equal to AD. This angle is equal to that one and this side is common. Now you guys see, if I just prove this one, if I just look at the two triangles right here, if I just divide them and place them separately. So you guys see, one triangle is like this, another triangle is like this, and you see this is ACB and that is ADB. Now in both cases you can see AB is common, these two angles are equal and that side is same as that one. Now in this case you can see we are talking about side angle side criteria, right? Because we have a common angle and both of the adjacent arms equal, so we will be using side angle side criteria. So in this case, AC is equal to AD, angle CAB is equal to angle DAB, AD is equal AB is equal to AB. That is common, right? AB is equal to AB. Write the reasons for them. This is given. This is also given. This is common. Now you guys see side angle side, triangles ACD and triangle ABD, ADB both are congruent. ADB both are congruent, and this is what you had to say. Now once you have proven the things which are congruent, then you have a special ability, then you can prove the remaining portions congruent too. That means if these two triangles are congruent, then you can easily say that these two sides will also be congruent, these two angles will also be congruent, this angle will be also be congruent. That means once you have proven two triangles congruent, then you can, if you have taken any three of its values to prove your proof, then you can prove the remaining portions to be congruent. That means you can easily say that angle ACB that you haven't taken in the proof will be same as angle ADB. This is called CPCT, which is congruent part of congruent triangles. So when you have made sure that the pair of triangles are congruent, then remaining portion of both of the triangles will be congruent too. That means this ACB will be same as ADB. You can say angle ABD will be same as angle ABC. These two will also be equal, and you can also say that BC is equal to BD. All these things can be proven with the help of CPCT, which is congruent part of congruent triangles. And you guys already remember, if the pair of triangles are congruent, then all 6 corresponding values are congruent. You guys see, AC was congruent to AD, angle CAB was congruent to angle DAB, ABAB was common, and remaining CBC will be congruent to DB, or you can say BD, and angle BAD, or sorry, ABD and ABC, they will be equal, and angle ACB and ADB, they will be equal to. So if you have proven 2 triangles congruent, then you can easily prove that the remaining portions will be congruent too. I hope you guys have understood the case and you don't have any doubt in this. Now let's move forward and see what do we have. We have the second question with us. This is very important. It states that ABCD is a quadrilateral. ABCD is a quadrilateral in which AD is equal to BC. AD is equal to BC, and angle DAB, this complete angle, is equal to angle CBA, that means this complete. Now you have to do what? You have to prove triangle ABD, that means this triangle, is congruent to triangle BAC, that means this triangle. Then you have to prove that BD is equal to AC. You have to prove this one, BD is equal to AC. And finally, you have to prove that angle ABD is equal to angle BAC. ABD, that means this angle will be same as BAC. This. So that is the thing that you have to do. Now this is quite easy and important. Now for this, in our first part, we have what? Triangle ABD and BAC. Now first, let's draw ABD. So ABD is like this. A, B, D. And what about BAC? BAC is like this. Right? B, A, C. So these are the things. I know angle DAB, which is this one, is equal to angle CBA, which is this one. These two angles are equal. I know AB is common to both, and I do know one more thing, that AD is equal to BC. Now you guys see, side, angle, side, side, angle, side. So using SAS, you can say both of the triangles are congruent. Then you have to prove that BD is equal to AC. BD is here, AC is here. They can easily be proven congruent using CPCT. Then you have to prove angle ABD, which is this one, equals to angle BAC, which is this one. They can also be proven equal using CPCT. So this will be the proof that we have to do. I'm going to erase this and start with the proof now. So let's see what do we have in this. So for this, firstly, let's write given. ABCD is a quadrilateral. ABCD is a quadrilateral in which AD is equal to BC. AD is equal to BC and angle DAB is equal to angle CBA. Now required to proof is what? Required to proof is all these three things. You have to write them down here, write them down on your own. Now let's come to the proof. For this, we just have to prove these two triangles congruent, and remaining two portions can be easily proven equal. So for this, I'm going to do what? I'm going to take two triangles in triangle CBA and triangle DAB. A and B are opposite, C and D are opposite. So that will be the case, or you can just take their names as it is that they are given. You can write them like this also. BAC and ABD. Name them like this. ABD and BAC. So you guys see, I know AB is equal to BA, which is common. I know angle BAC, sorry, not BAC, actually DBA, angle DAB, angle DAB, which is this angle, is equal to angle DAB equals to angle CBA. This is also given, and I do know AD is equal to BC. This is also given. So you guys see, side, angle, side, triangles ABD and BAC both are congruent, and you can say BD equals to AC, CPCT, because that is the part of the congruent triangles, and angle ABD equals to angle BAC, also CPCT. So these are the things that can be proven equal once you have proven your triangles congruent. So I hope you guys have understood the case and you don't have any doubt in this. because that will be a necessary thing. Remember, if you have proven two triangles congruent, then only you can say the remaining portions of the triangles will be congruent too, provided you haven't used those parts in proof. You cannot say that if you have taken AD equals to BC in the proof and you can say AD is equal to AB also. That cannot happen because these two are equal themselves. These two cannot be equal, because if that is the case, then the figure will be totally different. So once you have taken a pair of sides or angles in the proof, you cannot use the same pair of sides or angles to prove that they are equal to something else, because they are already proven equal to one thing, they will not be equal to another thing. So that will be an important thing to understand. I hope you guys have understood this. Now let's move forward and see. We have this third example with us. It is AD and BC are equal perpendiculars. AD and BC are equal perpendiculars. This side is equal to that one. And show that CD bisects and CD bisects AB. We have to show that OB is equal to OA. Now you guys see, this is point C. So CD bisects AB. We have to show that OB is equal to OA. Now for this, you guys know this side is same as that one. This is 90. This is 90. That will be equal. This angle will be same as that one. So angle, angle, side. Triangles will be congruent, and you can easily say OA is equal to OB using simplicity. So proof is quite easy. So required to proof was OA is equal to OB. Now for the proof in triangle OBC and triangle OAD. OBC and OAD, I know BC is equal to AD. I know angle CBO equals to angle DAO 90 each. This is given. And I also know this angle AOD equals to angle BOC. This is vertically opposite angles. So you guys see, angle, angle, side, triangles are congruent. So triangle OBC is congruent to triangle OAD, and simply you can say OB is equal to OA BCT. So this is the proof. I hope you guys have understood the case, because this was quite easy question. I hope you don't have any doubt in this. So this was a pretty straightforward sum. So this is the proof right here. Now let's move forward and see what do we have in the fourth part. So we have this fourth question with us. This is very important. Remember, this is very important. So in this we have L and M are two parallel lines. L and M are two parallel lines, and another pair of parallel lines are P and Q, such that P and Q are acting as transversals to L and M. We have to show that triangle ABC, which is this one, is congruent to triangle CDA, which is this one. So we have to show these two triangles will be congruent. Now in this case, before we get to the point, now you guys see L is parallel to M and P is parallel to Q. Now you guys see, if this is the case, if P is parallel to Q and AC is the transversal, this angle right here will be same as this one, right? This angle right here will be same as that one, and this side is common, right? See, let me just tell you one more thing, one more time. See, if P and Q are parallel, so you can say AB will be parallel to DC also. So if this is the case and AC is the transversal, or you can say ABCD is a parallelogram in this case, or you can just simply say AC is a transversal, then you can say this angle right here will be same as this one, alternate interior. This angle right here will be same as this one, alternate interior, and this side is common. So angle, side, angle, triangles are congruent, and you have just proven your answer. So we have been given what? Given is P is parallel to Q and L is parallel to M. So if P is parallel to Q, then I can say AB is parallel to CD and AC is the transversal, right? AC is transversal. Therefore, I can say this angle DAC will be equal to angle BCA, and angle DAC will be equal to angle BCA. Alternate interior angles. These are the things, right? Now required to proof is triangle ABC should be congruent to triangle CDA. We have to prove this one. Now this is quite straightforward. So proof now. In triangle ABC and triangle CDA, you guys see, I know angle DAC equals to angle BCA. I know AC is equal to AC, and I know angle BAC equals to angle DCA, right? All of these things are, this is proven. This is proven because we had proved this, right? And this was common. Or you can do what? You can write alternate interior angles here. So you guys see angle, side angle, triangles ABC and DCDA both are congruent, and you can similarly prove anything that you want. You can easily say AB is equal to CD, you can say AD is equal to BC, or you can say angle B is equal to angle D. So these will be CPCT. If that is the case, you can easily say that ABCD is a parallelogram. So this will be coming handy while you are in your chapter quadrilateral. We will be using these properties to show that a given figure is parallelogram or not. These will be coming handy in those theorems. So I hope you guys have understood the case and you don't have any doubt in this. And let's move forward now and see what do we have. So this is another question from exercise 7.1. This is fifth question. It states that L is the line bisector of angle A. L is the line bisector of angle A. This is the line bisector. That means this half is same as that one. And B is point on L such that BQ and BP are perpendicular. You have to show that APB should be congruent to AQB. This is quite easy. You have to show that APB, which is this one, should be congruent to AQB. Now you guys see, this is 90, this is 90. This angle same as that one, this is common. Angle, side. Triangles are congruent, and you can easily say that BP is equal to BQ, or you can say B is equidistant from angle A. That is the proof we have to do in this. So you can easily do this one. I hope you are able to solve this. So I will be leaving this for your homework. This will be your homework. If you are having any doubts, you can just log on to our website and post your doubts there. You can get yourself registered and you can have your doubts shared with me. I will be happy to clear your doubts also, and we will be happy to have you there. So let's move forward and see what do we have. So for today, I will be wrapping up now. So we have understood our various congruency criteria. They were your side criteria, side angle side criteria, angle side angle criteria, and angle side criteria. We also understood that why there was no such thing as side angle criteria and why was no such thing as angle side criteria. So these are the important things that you should remember. Side means in a pair of triangles, if the corresponding sides are equal, then the triangles will be congruent using side criterion. If in a pair of triangles, two sides including the angle between them are congruent, then you can say you have used side angle side criteria and the triangles are congruent. In a pair of triangles, when you have two angles and the common vertex common arm sharing both of the angles, if those three are equal, then you can say you have used angle side angle criteria. Similarly, if you have two different angles and a third side equal to another triangle like this, so you can say you have used angle side criteria. So these are the most important things that you should remember. We will be following up with this chapter tomorrow with our next session, in which we will be having some remaining sums of your exercise 7.1, and I will be having that next portion of your chapter. We will be completing this chapter quite in 4 or 5 sittings. So till then, remember, you have to revise each and everything each day. You cannot skip anything from these. These are very important theorems. So I'll see you in the next session tomorrow. Till then, practice as much as you can. Bye for now.